Section 2.5, Inequalities. Before we get started on solving and graphing inequalities, let's just recall a couple things about inequalities themselves. If you are given this, x is greater than 2, x is greater than 2 means any numbers that are greater than 2. If I wanted to create a set, I could say, well, that would include the numbers 3, 4, 5, 6, and it would go on forever and ever. Remember, though, x is greater than 2 also would be numbers anything greater than 2 at all. So it could be 2.1, 2.01, anything at all that is just greater than 2. It's not going to start at the number 3. If you are given this symbol, and it is an underlined symbol there, that means x is greater than or equal to 2. So once again, if I want to do this set of that, I would be doing 2, 3, 4, 5, and so forth. But once again, remember that for both of these, I'm not just talking about integers. I'm talking about any numbers at all that are greater than 2, including the decimals, the fractions, things like that. So I could also, for this, I could be saying, well, 2.5 and 5.16, anything at all that is greater than or equal to 2. I'm going to write this same expression that I have right here, x is greater than 2. I'm going to write it a different way. I'm going to write it like this, which many people may say, well, 2 is less than x. Well, if 2 is less than x, once again, that is meaning exactly the same thing as everything that I put up here. Because if 2 is less than x, that would mean that x could be 3, 4, 5, 6, and so forth. But I wrote it, some people would say backwards, 2 is less than x. It's not really backwards, but it is understood in math that generally if you have an inequality and you have a variable, generally you are going to see in the book that they have the inequality written to the left and the number written to the right. Now, as I say, you don't always have to do that, but that generally is the way that you are going to see the answers written. As I said, though, this section also deals with graphing the answers on a number line. So, if you are given the problem, x is greater than 2, what you need to do is you need to graph this on a number line. So I have a number line here, and I want x being greater than 2. In order to show that on a number line, I am going to put an open circle on 2, and I'm going to draw an arrow to the right. And what that shows is that shows all the answers from 2 on, that x could be anything from 2 on. But the open circle shows that it does not include 2. If I wanted to show the answers on a number line, I got x is greater than or equal to a -1. This time I am going to have a closed circle on -1. And once again, I want to show all the values when x is greater than -1, which means that I would be going to the right-hand side and I'd be drawing a line. And notice I'm just putting an arrow in there indicating that it goes on forever and ever. If I had something like x is less than, let's say, a -3, I'd be putting that open circle on -3, and I would be going and drawing an arrow to the left, showing that all the values of x have to be less than or equal to -3. So once again, just remember that if it does not include the number, if I do not have a line underneath, then it's going to be an open circle. If I do have the line beneath, then when I put the spot on the graph, it's going to be a closed circle. So let's combine the above ideas with just going through and solving some inequalities. Here I have x plus 5 is less than 4. I'm going to do this just like I would do an equation. The very first thing I'm going to do is I'm just going to subtract 5 from both sides. When I subtract 5 from both sides, I get a final answer of x is less than a -1. And then you need to go through and you need to graph that. x is less than -1. I'm going to put an open circle on -1, and I want to show all the possible values for x, so x could be anything to the left of -1. Now, you also want to check this. So I could pick any value that I have in here. So it looks as if -3 is a possible value. If I put -3 in here and solve this, is it true? Is -3 plus 5 less than 4? Well, -3 plus 5 is equal to 2, and 2 is less than 4. So it does check. Here's another example. 5x is less than 4x plus 1. In order to solve this, I am going to go through and subtract 4x from both sides. If I subtract 4x from both sides, I get x is less than 1, which once again I'm going to go through and I'm going to show on a graph. I'm going to have an open circle. I want to show all the values when x is less than 1, so I'm going to draw it to the left, and there is the answer. Here's one in which I need to divide by the coefficient. I have a 5 in front of the x. I'm going to divide both sides by 5. When I divide both sides by 5, I get x is less than or equal to 4, which once again I'm going to show on a number line. This time I'm going to have a closed circle, and I want to show when x is greater than 4, so I'm going to go off to the right hand side, and there I have the answer. The most important part that you need to be careful about this is when you are multiplying or dividing by a negative number when solving inequalities. Here I have -x is greater than or equal to 3. Well, before we do anything with this, what are the possible values for this? Well, I want the opposite of x to be greater than or equal to 3. So that would mean that x would equal things like a -3, or a -4, or a -5, because let me just take one of these. If I put -4 in for just the x, I want the opposite of a -4, which is a +4, and 4 is greater than 3. So these values that I'm starting to list up here are going to be the correct values. X could be -3, -4, -5, -6, and I'm going to show that here on my number line. These would be the possible values for what I have, that inequality. The opposite of x is greater than or equal to 3. But let's look at what happens if I go through and if I just solve that. If I have the opposite of x is greater than or equal to 3, in order to get rid of the negative, I have to go through and divide both sides by a negative. Well, negative divided by negative gives me a positive. It looks like I have x is greater than or equal to a -3. And if I were to graph that, then I'm talking about these values, which is not the correct answer. So whenever you are given a problem that you have to go through and you have to either multiply or divide by a negative, once again, here's that original problem, you are going to just go through the regular process. I'm going to divide by a negative. I'm going to divide by a negative. I'm going to get x. I'm going to get -3. But what I have to do is I have to reverse the sign. Whenever you multiply or divide by a negative, you have to reverse the inequality sign, because we know that the answer to this is, as I have in the red here, we know that the answer is values that are less than -3, and this shows the values that are less than -3. So let's go through and solve a problem where we have to do that. Here I have -9x is less than 45. In order to solve this just for x, I am going to divide both sides by a -9. When I divide both sides by a -9, I get an x and I get a -5. But remember, because I divided by -9, I have to reverse the sign. So I get an answer of x is greater than -5. If I want to go through and graph that, I'm going to put an open circle at -5. I want to show all the values when x is greater than a -5. So I'm going to draw my arrow off to the right-hand side. Let's look at just a couple more examples. As you can see in this problem, I want to get the x's together, so I am going to subtract 5x from both sides. When I subtract 5x from the left-hand side, I get a negative 3x is greater than or equal to 18. Now I'm going to go through and I'm going to divide both sides by a negative 3. When I divide by a negative 3, I end up with x on the left-hand side. I end up with a negative 6 on the right-hand side. But remember, I need to reverse my sign. So I get x is less than or equal to a negative 6, which means now when I go through and I graph this, I'm going to put a closed dot at negative 6, and I'm going to show all the values that are less than a negative 6. Remember that you need to reverse the sign whenever you multiply or divide by a negative. So here I'm going to multiply both sides by a negative 2. If I multiply both sides by a negative 2, the negative 2 and the negative 2 cancel. I'm just left with x. A negative 2 times a negative 2 gives me 4. So I'm going to reverse my sign because I multiplied by a negative 2. I'm going to get an answer of x is less than 4. So when I go through and I'm going to graph this, I have x is less than or equal to 4, I should say. My arrow is going to go off to the left. Once again, whenever you're doing this, make sure that you always check an answer and make sure. It looks here like 0 is going to be a solution for this because 0 is where that line is being drawn to. The original problem was x divided by negative 2 has to be greater than a negative 2. If I put 0 in for x, is this a true statement? Well, 0 divided by negative 2 is greater than or equal to a negative 2. Well, 0 divided by negative 2 is 0. Is 0 greater than or equal to negative 2? Yes, it is. So I did draw my line going the correct way. As I said, the most important part of this section is to make sure that you reverse the inequality sign when multiplying or dividing by a negative number. Other than that, you are really just going through the same process of solving equations, which we have been doing for some time. If you have any questions, please be sure to ask.